Hello friends, grab your coffee, grab your cookie, but maybe keep the cookie away from the sugar line, because today we are talking about sugar dust. Yes, that sweet, innocent-looking dust that coats every surface, clogs every filter, sticks to every moving part, and has caused some of the most devastating dust explosions in the food industry. My name is Michael Klepik, and for 15 years I have been designing air filtration systems for sugar mills, refineries, confectionery plants, bakeries, and packaging operations. Let me walk you through what sugar dust really is and how we control it safely. What sugar dust really is? Technical description. Sugar dust is composed of extremely fine sucrose crystals generated during crushing, grinding, sifting, drying, and conveying of sugar. Its technical characteristics include: first, particle sizes typically range from 1 micron to about 400 microns. Second, the most explosive fraction is between 10 and 50 microns. Third, bulk density of powdered sugar dust is usually from 400 to 800 kilograms per cubic meter. Fourth, airborne concentrations can reach from 1,000 to 20,000 milligrams per cubic meter during milling or packaging. Fifth, sugar dust is highly hygroscopic and becomes sticky when exposed to humidity. Sugar dust may look like powder, but chemically it behaves like fuel. Where sugar dust appears in industry. Sugar dust is produced at nearly every step of sugar handling. First, refining, crushing, and grinding of raw sugar. Second, milling and powdering of granulated sugar. Third, screening and classifying operations. Fourth, conveyors, bucket elevators, and transfer points. Fifth, bagging, packing, and sachet filling. Sixth, confectionery production and mixing of powdered sugar. Even small leaks in a conveyor or mixer can release large clouds of sugar dust. Why sugar dust is dangerous. Sugar dust is one of the most combustible food dusts in industry. Here is why. First, it has a very low minimum ignition energy, so even small sparks or hot surfaces can ignite it. Second, dense sugar dust clouds explode violently when confined. Third, sugar dust layers ignite easily and fuel secondary explosions. Fourth, sugar attracts moisture and forms sticky deposits. Fifth, sticky sugar clogs ducts, fans, and filters. Sixth, fine sugar particles irritate the respiratory system. The 2008 refinery explosion in the United States was caused by airborne sugar dust, a tragic reminder of its hazards. Physical behavior of sugar dust in airflow. From an engineering perspective, sugar dust is challenging because, first, it is lightweight and floats easily in moving air. Second, it forms dense white dust clouds during pouring or mixing. Third, it absorbs humidity and becomes sticky in ducts. Fourth, sticky sugar reduces filter life and increases pressure drop. Fifth, the smallest particles behave like smoke and require high-efficiency media. Because of these behaviors, I designed duct velocities from 4,000 to 5,000 feet per minute for sugar dust. What filtration equipment works? Best sugar dust requires rugged, high-efficiency filtration systems. For fine powdered sugar dust, I often use a FOEHN cartridge collector. First, it captures fine sucrose crystals efficiently. Second, it offers strong pulse cleaning with membrane-coated media. Third, it provides a large filtration area for high dust loads, for heavy dust loads in sticky environments. A Baghouse Blizzard is often the best choice. First, it tolerates heavy, sticky dust loading. Second, it maintains stable airflow during long production cycles. Third, it is reliable for high-volume sugar transport systems. Explosion protection. Because sugar dust is fully combustible, I always include, first, explosion vents on the collector. Second, isolation valves in ductwork. Third, anti-static filter media. Fourth, grounding and bonding across all equipment. Fifth, optional spark detection in milling lines. Safety must come first in every sugar handling facility. Capture hood design for sugar processing. Good hood design significantly reduces airborne sugar dust. Effective methods include: first, enclosed hoods on sugar grinders and mills. Second, capture points at bag dump and mixing stations. Third, side draft hoods along conveyor transfer points. Fourth, enclosed filling and packaging lines. Fifth, dust pickup on bucket elevator heads. Even small openings can release large clouds of sugar dust. The most common mistakes I see with sugar dust. Across sugar refineries and food processing plants, I frequently see: first, using standard filters not designed for sticky sugar dust. Second, running duct velocities too low, allowing sugar to accumulate. Third, ignoring explosion protection requirements. Fourth, using poorly enclosed bag dumping stations. Fifth, not grounding the system. increasing static risks. Sixth, allowing sugar dust to accumulate on lights, beams, and equipment. These mistakes significantly increase fire and explosion risks. What I always do on sugar dust projects, my engineering method includes, first, identifying the sugar type and dust fraction size. Second, designing ductwork specifically for lightweight, sticky particles. Third, selecting membrane-coated media for long filter life. Fourth, including full explosion protection and duct isolation. Fifth, enclosing every dust generation point carefully. Sixth, using anti-static materials throughout the system. Seventh, making sure the system is easy to clean because sugar sticks everywhere. These practices ensure consistent air quality and safe operation. Sugar dust may look sweet and harmless, but it is one of the most dangerous combustible dusts in food processing. It spreads easily, sticks to everything, ignites quickly, and forms explosive clouds during normal operations. With proper airflow, high-efficiency filtration, and full explosion protection, sugar dust can be controlled safely and reliably. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, sugar belongs in your dessert, not suspended in the air like a sweet storm. See you in the next video.